In today's video, I'm gonna answer the question, what causes insulin resistance? Too much fat, too many carbs, or is there anything else? And as always, I'll answer the question using science. So first, you might have noticed that there are 4 main camps when it comes to the cause of insulin resistance. The first one states that the cause of insulin resistance is unknown. Does it make any sense? Do we not have any biochemical and experimental data that would give us the answer? People who state this simply haven't done their homework. Next. Then the second camp states that the cause of insulin resistance is excessive calories. Well, that's partially true. Too many calories will lead to insulin resistance. But excessive calories is not the starting point in insulin resistance. It's a consequence of something else. I'll come back to this later. And there are 2 more reasonable camps and their theories about the cause of insulin resistance. Both have, as it seems, strong scientific basis that has a few things in common and a few facts contradicting each other, which can leave many people confused about the true cause of insulin resistance, resulting in them not knowing what diet and lifestyle should they follow to reverse insulin resistance. After watching this video, you will have a much better understanding of what is insulin resistance, what causes it, and how to reverse it. The first one says that fat causes insulin resistance, and the second says that carbs cause insulin resistance. I'll explain both sides, give you the facts, look into the research, explain the mechanism of each, and let you decide which one makes more sense to you. Just a quick background before I look into both. One of the roles of insulin is to allow glucose to enter the cells, where it can either be used as energy or stored for later use in the form of glycogen or body fat. Each time we eat, we trigger insulin. The more times we eat, the more insulin we have in our bodies. And depending on what we eat, we can have a different insulin response. Now let's go back to the 2 camps with different insulin resistance ideologies. Just don't run away straight when you hear something that you don't like or don't support. It is very important to understand both sides of the argument so that we would know for sure what's the actual cause of insulin resistance. Both theories have a lot of valid points. Let's start with the first one. Fat causes insulin resistance. How? There are several studies showing that higher fat intake is associated with more insulin resistance. That's the most common publicly accepted view. There are some short-term studies showing that if you increase someone's fat intake, they instantly get decreased carb tolerance, increased insulin resistance, and elevated blood glucose. We could end the argument there, but it's not as straightforward. I'll come back to this later. Vegetarian and vegan diets are based on the idea that fat is harmful, especially animal fat. According to plant-based doctors, fat, and especially animal fat, causes insulin resistance, type 2 diabetes, heart disease, dementia, obesity, and every other disease that you could imagine. Now, we have to understand that when looking into nutrition and health studies, we mostly have observational studies, which can show correlation, but can never prove causation. Most of the research supporting this view comes from observational studies that compare people on the low-fat diet and people on the standard American diet. That is a diet with most calories coming from ultra-processed foods, refined grain products, sugar, sugary drinks, refined vegetable oils, poor quality factory-raised animal products, very little amount of vegetables. You see the picture. These studies show that people who eat the least fat are the least insulin resistant and less likely to develop diabetes, heart disease, and other diseases. Knowing how bad is the standard American diet, I'm not surprised that removing some of these unhealthy foods and replacing them with better options like whole grains instead of refined grains, less vegetable oils, more fruits and vegetables results in less insulin resistance and type 2 diabetes. But I would like to see a more fair comparison, where 2 health-focused diets are compared. I'll share one very interesting study later. Now let's look at the arguments for the biochemical side of it. There's an observation that saturated fats such as the palmitic acid tend to accumulate in the muscle, liver, and other areas, making these tissues more insulin resistant. The proponents of this camp say that a whole body gets clogged with fats as a result of eating animal fat, which results in our bodies struggling to use glucose as fuel. This sequence of events in developing insulin resistance goes like this. You eat meat, cheese, eggs, and other fatty foods. They raise your blood lipids. You have elevated LDL bad cholesterol, elevated triglycerides, elevated palmitic acid, which is saturated fat. It accumulates in your blood. It clogs your arteries, your muscles, your liver. It makes you store excessive body fat and get all sorts of diseases. Because of excess fat clogging the whole body, clogging insulin receptors, you become insulin resistant, and your cells struggle to let glucose in and use it as fuel. Glucose builds up in the blood, which over time results in type 2 diabetes. The vegan diet suggests stopping 100% of all animal products, because animal products contain saturated fat that goes in the blood, clogs the arteries, clogs the liver, clogs the muscles. According to this ideology, fat has very little use in the body. Yeah, fat is surely not important. Our brains are made of fat. Every single cell membrane in our bodies is made of fat. Hormones are made of fat. But who needs fat? They often recommend very low-fat diets with only 10% of calories from fat, while the general definition of a low-fat diet is around 30% of calories from fat. Most plant-based diets encourage to lower fat even further, and obviously the fat then has to be replaced by carbs. Most calories, 60 to 70%, could be coming from carbohydrates. Let's do a quick fact check. What do they mean by a high-fat diet in these studies? Well, it's actually a moderate carb and moderate fat diet, with around 35 to 40% of calories coming from fat. And the fat sources are definitely not healthy. In some of these studies, participants are often eating a lot of refined carbohydrates and a lot of poor quality fats, such as refined vegetable oils. This combo doesn't do well together. When you eat protein and carbs, or fat and carbs, this increases glycation. That's a process where glucose binds to fat or protein molecules, damages them, resulting in accumulation of advanced glycation end products, or AGEs. Is it a good representation of a high-fat diet? Well, not at all. And then they continue with saying that a high-fat diet causes insulin resistance. It is true that our bodies prefer running on either carbs or fats, not both at the same time. But does fat on its own, without the carbs, cause insulin resistance? To answer this, let's look at the second camp, which states that not fat, but carbs cause insulin resistance. I mentioned earlier that different foods have different effects on our insulin. As a general rule, high carbohydrate foods have the highest blood glucose and insulin response. That's because foods high in carbohydrates are broken down into glucose. This glucose requires insulin so that it could enter the cells. With insulin resistance, you have impaired glucose metabolism. You eat carbs, it increases your glucose and insulin. Your cells resist insulin and don't let glucose in. Your body tries to compensate by producing more and more insulin so that it could push that glucose into the cells. You get chronically elevated insulin and chronically elevated glucose, which over time progresses into type 2 diabetes. Too much glucose and too much insulin is what drives insulin resistance. In addition, there's data that suggests that carbohydrates are the least satiating from all macronutrients, resulting in hunger returning much sooner after eating. This could partially be explained by the huge blood glucose fluctuations caused by high carbohydrate meals. You get a glucose spike, it drops. It raises again, it drops. Each time when glucose drops, there's where the hunger and tiredness kick in. Eating carbs results in the biggest blood glucose fluctuations, and this leads to more hunger, cravings, mood, and energy swings. A high-fat diet reduces your insulin and your insulin resistance because fats have the smallest impact on your blood glucose and insulin. You no longer eat carbs that spike your blood glucose and insulin, and you replace it by extra fat that has minimal effects on your blood glucose and insulin. Type 2 diabetics report instant drops in blood glucose, bringing their blood glucose to a normal non-diabetic range. The best representation of a high-fat diet would be the low-carb, high-fat, moderate-protein ketogenic diet, with typical macros: 5% calories from carbs, 75% from fat, and 20% from protein. Now, that's the real high-fat diet. It's not the 40% fat diet that is often cited in insulin resistance studies. If we look at this study, they compared blood glucose response after a high-carb meal and a low-carb, high-fat meal. As we see, a high-carb meal resulted in a huge blood glucose spike, while the high-fat meal resulted in stable, normal blood glucose levels. When we have stable blood glucose levels, we also have stable energy, stable mood, and we don't get hungry as quickly, and we don't spike insulin as much. And as we're less hungry, we can go longer periods of time without eating. That's another way how we can keep insulin low. According to this camp, too much insulin caused by a high carbohydrate diet and frequent eating causes chronically elevated insulin, which then leads to insulin resistance, type 2 diabetes, dementia, heart disease, and so on. So according to the first camp, all of this fat, especially animal fat, is supposed to raise blood triglycerides, bad LDL cholesterol, cause fat accumulation in the liver, in the muscles, and so on. Now, if we find fat in the blood, if we have high cholesterol, high triglycerides, if we have palmitic acid, which is saturated fat, accumulating in our muscles, it is easy to assume that eating fat causes fat accumulation in the blood, liver, muscles, and adipose tissue. But let's look at this research paper. It says that this fat clogging the body is a result of the high carbohydrate diet. It talks about de novo lipogenesis. De novo lipogenesis simply means making new fat from carbohydrates. It is a complex and highly regulated process in which carbohydrates from circulation are converted into fatty acids that are then used for synthesizing either triglycerides or other lipid molecules. This regulation of de novo lipogenesis contributes to human diseases such as obesity, type 2 diabetes, and cardiovascular disease. That's exactly the fat that accumulates all over the body, clogging the liver, the muscles, our fat cells, and the same fat accumulates in our blood. And then they say, a high-fat diet inhibits lipogenesis, meaning a high-fat diet stops your body from making fat. It makes you lose fat. It makes you break down the fat that has accumulated in your liver, in your muscles, and in your adipose tissue. As we see, things are not as straightforward. There's a study showing that just 6 days of a ketogenic diet drastically reduced liver fat. If the first camp got it right, the high-fat diet is supposed to cause severe insulin resistance and type 2 diabetes. If we check studies, we see the opposite to be true. The high-fat, low-carb diet reduces insulin concentrations, reduces insulin resistance, and greatly improves type 2 diabetes, often leading to type 2 diabetes remission. Let's do a fact check again. Which diet, the low-fat diet or the high-fat diet, is better for blood lipids and insulin resistance? Let's look at this study, a comparison of the low-fat, high-carb diet versus the high-fat, low-carb diet on blood lipid profile and insulin resistance. The low-carb diet was defined as around 10% of calories coming from carbs, and the low-fat group was less than 30% calories coming from fat. We see that the low-fat, high-carb diet is marked in red, and the high-fat, low-carb diet is marked in yellow. And if it's on the right side, it means it decreased. And if it's on the left side, it means that it got increased. So we see that both diets decreased ApoB, but the high-fat diet, marked in yellow, decreased it much more. Some studies suggest that ApoB can help to determine your risk of heart disease much better than the commonly measured LDL cholesterol. meaning that the high-fat diet is more effective at decreasing your risk of heart disease. We can see that total saturated fatty acids in the blood have greatly decreased with the high-fat diet. It decreased by almost 60%, compared with only 20% decrease with the low-fat diet. This shows how a high-fat diet decreases your blood saturated fats. It does not increase it, which contradicts what the plant-based diet proponents suggest. Then, small LDL-C particles, the ones linked with heart disease, were actually slightly increased with the high-carb, low-fat diet, while it got decreased by around 20% on a high-fat diet. Then next, triglyceride to HDL ratio, which is a very good predictor of coronary disease. The lower, the better. It got decreased by more than 50% with the low-carb, high-fat diet, while it decreased only by 20% with the low-fat diet. Then the HDL, good cholesterol, increased by around 10% on a high-fat diet. It got slightly decreased with the high-carb diet. We need higher HDL to decrease our heart disease risk. Then triglycerides got decreased by more than 50% with the high-fat diet and only by 20% on a low-fat diet. Are these the same triglycerides that are supposed to be elevated with the high-fat diet? Again, they got decreased more with the high-fat diet. Next, HOMA-IR. It's a test to assess insulin resistance. If your HOMA-IR is high, your body is using more insulin than normal to keep your blood sugar normal. The higher the number, the more insulin resistant you are. We see that the high-fat diet decreased HOMA by around 56%, compared with only 18% decrease with the high-carb diet. Also, there's a possibility that the results seen on a high-carb diet are simply a result of consuming less calories. And still, it shows that the high-fat diet is more effective for reducing insulin resistance when compared with the low-fat diet. Then insulin decreased by 50% on a low-carb, high-fat diet and only by 17% on a low-fat diet. Glucose decreased more with high fat, abdominal fat decreased more with high fat, and body mass decreased more with high fat. A high-fat diet reverses all coronary risk factors more effectively than the low-fat diet. You might be thinking, the low-fat diet group was not low enough on fats. Are there any better studies? Are there any other studies looking at how the low-carb, high-fat ketogenic diet compared to a higher carb, low-fat diet affects insulin levels and insulin resistance? Yes, there are a few more studies. There's a study called Comparison of Isocaloric, Very Low Carbohydrate, High Saturated Fat and High Carbohydrate, Low Saturated Fat Diets on Body Composition and Cardiovascular Risk. They compared 3 different diets and measured insulin levels. There were 83 subjects. They were randomly allocated to one of 3 weight loss diets with the same number of calories for 8 weeks and on the same diets in energy balance for 4 weeks. The first diet was a very low-fat, high-carb diet with these macros: carbs 70% of calories, fat 10% of calories, and protein 20% of calories. The second high-carb diet was high in unsaturated fat. The macros were as follows: 50% carbs, 30% fat, and 20% protein, with only 6% of fat being saturated. The third diet was a very low carbohydrate, high fat diet with macros as follows: 4% carbs, 61% fat, 35% protein, and 20% of the fat was saturated fat. So if saturated fat is the problem, this diet should cause most insulin and most insulin resistance. Looking at the results, we can see that the very low fat, very high carb diet, marked in orange, resulted in the highest levels of insulin, and that the high fat, low carb diet, marked in green, resulted in the lowest levels of insulin. This clearly shows that the high fat, high saturated fat diet has nothing to do with causing insulin resistance. It helps you to lower insulin and reverse insulin resistance. And we see that the other low-fat, low-saturated fat group was a bit better than the highest carb group, but was still pretty bad. So the results show how the high-fat, high-saturated fat diet wins the fight. I will leave the reference list in the description of this video in case you want to read these studies yourself. And trust me, I looked really carefully and fairly into both diets, but the evidence to support the low-fat plant-based diet for reversing insulin resistance and type 2 diabetes simply isn't there. And the biochemical side also fails, as it is based on the idea that animal fat equals blood lipids, equals body fat, equals insulin resistance and diabetes, while they get it wrong since the beginning. It's the carbs getting turned into harmful fat through de novo lipogenesis. Dietary carbs have not many functions in the body. All our glucose needs can be met without eating carbs, through the process of gluconeogenesis, which is making new glucose from protein and fat. And some would still say, glucose is our preferred fuel source. If the body has a choice, it will burn glucose first. Yeah, that's right. The body will burn the most toxic or the most useless fuel first. In the presence of alcohol, it will use alcohol first. Does it mean that alcohol is our preferred fuel source? So why are these carbs turned into fat? Well, firstly, we have very limited glucose storage capacity, while we have almost unlimited fat storage capacity. Also, knowing that fat is used as a structural component in every single cell in our bodies, I'm not surprised that body turns carbs into fats. Fats are much more useful, while carbs are non-essential and, as we see with insulin resistance and type 2 diabetes, also quite problematic for most people. So what's our actual preferred fuel source? It's ketones. It's a much cleaner, much healthier fuel that creates more energy and less free radicals when compared with glucose. Ketones are therapeutic for the brain and the rest of the body. If you check out some research studies of any chronic health condition and the effects of keto diet for that condition, you will most certainly find that keto is beneficial. Why is keto that good? I believe that's the way our bodies are designed to eat. I hope this video helped you to realize what causes insulin resistance, fat or carbs. If you found this video useful, give it a thumbs up and subscribe to my YouTube channel. Feel free to support my channel on Buy Me a Coffee or Patreon. Thanks so much for watching, and I hope to see you in the next video.